Hey everyone, it's Miss Brooks with your daily dose of math. Today we're going to be studying section 3 of chapter 1, solving equations with a variable on both sides. But before I jump straight into variables on both sides, we're also going to take a look at solving equations that have multiple fractions and how we can easily work with those equations rather than having to constantly add, subtract, multiply, or divide fractions in the problem. Our first example we're going to take a look at is being able to solve equations that have multiple fractions. Now, while you can solve these types of equations just by simply adding the fractions, subtracting the fractions, multiplying them, or dividing them, it's a lot easier when you have fraction problems to just simply clear the fractions and have whole numbers to work with. So we're going to talk about how do I clear the fractions from the problem. So anytime you have fractions, whether it's one fraction or multiple fractions, you can use this procedure I'm about to show you. What we want to do when there's fractions in the problem is narrow in and take a look at your denominators. In this case, we have a denominator of 4, we have a denominator of 12, and we have a denominator of 8. When I want to clear these fractions, what I want to do is I want to multiply every single part of my equation, fraction or not, by my least common denominator. Now, your least common denominator is the number that all of your denominators can go into. So what I want to think of right now is there some number that both 4, 12, and 8 can go into? That number, of course, is 24. 4 goes into 24, 12 goes into 24, and 8 goes into 24. So what we are going to do is multiply every single part of our equation, whether it's a fraction or not a fraction, by the number 24. So in this case, I'm going to multiply the fraction 3m over 4 times 24. I'm going to multiply m over 12 times 24. And I'm going to multiply 7 over 8 times 24. So when I multiply each piece by 24, I then want to simplify. So what that means is I'm going to take a look at the first fraction, 3m over 4. 4 goes into 24 6 times. So in other words, I'm multiplying the numerator 3m by 6. So 3m times 6 is telling me that is now 18m. The 4 canceled out because it goes into 24. I then repeat the process with the next one, m over 12, multiplying it by 24. Well, 12 goes into 24 2 times. So essentially I'm multiplying the m with 2. So I'm subtracting 2m. The 12 canceled out again because it goes into 24. And then lastly, 7 over 8 with the 24. 8 goes into 24 3 times. So I'm multiplying 7 by 3 to get that that's 21. Again, the 8 cleared out because it went into 24. So just by multiplying by what we call the least common denominator, that is how we get the fractions to cancel out. And then we have a much easier equation to work with. At this point, on the left-hand side, 18m minus 2m is 16m, just by combining my like terms. And then I would divide by 16. 16 does not go into 21 perfectly, and there is no number that goes into both 21 and 16. So my final answer for this problem would be m equals 21 over 16. I now want you to try this problem. 1,290 equals h over 10 plus h over 5. Please pause the video and try yourself. When you have finished solving, resume the video to check your answer. To solve this problem, since there are multiple fractions, the first thing we want to do is clear the fractions. So if I take a look, I have a 10 and I have a 5. So what I want to do is multiply by my least common denominator. What is the smallest number that both 10 and 5 can go into? In this case, that's 10. So I'm going to multiply every piece of the equation by 10. That means that h over 5 gets multiplied by 10. The h over 10 gets multiplied by 10. And even the 1290 gets multiplied by 10. You have to change every component of the equation when you multiply by the least common denominator. So when we multiply everything by 10 in this problem, what is happening is we have 10 times 1290. That's going to become 12,900. H over 10 times 10. 10 goes into 10 one time, so that means we're just left with 1h, or h. 5 goes into 10 two times, so 2 times h, that means we have plus 2h. Now that all the fractions have cleared, this is a much easier problem to solve. We're going to drop down the 12,900, and h plus 2h would be 3h. Divide both sides by 3, and then do the division. 3 goes into 12 4 times, into 9 3 times, and then we have 2 zeros as a placeholder. So h is equal to 4,300, or 4,300. We're now going to take a look at solving a linear equation with variables on both sides. I have put the 5 steps here again. You do not need to copy them down. This is already in your notebook from the last set of notes. But what I want to talk about is that this time we are going to focus on doing step 3. And step 3 is to make sure we get all our variables on the same side of the equal sign. So step 3 comes into play on these next couple problems we're going to solve. Our first example of solving equations with variables on both sides is 7x minus 10 equals negative 2x plus 17. So what I'm going to do to solve this equation is, of course, split this into left side versus right side. And what I want to do is I want to get all of my variable terms on the same side of the equals. So what that means is I can either move the 7x to the other side with the negative 2x, or I can move the negative 2x over with the 7x. What I'm going to choose to do, because I like to keep numbers positive, is I'm going to move the negative 2x to the other side. Now I have to make sure when I move it to the other side that I do the opposite operation of what is currently happening. So right now this negative 2x, it's being added to a 17. So I essentially need to subtract this negative number. And remember, subtracting a negative is just the same thing as if I were to add that number. So what I'm doing is I'm going to add the 2x to both sides. I'm not actually trying to get the x by itself yet. I'm trying to get all the x terms together. So when I add 7x and 2x, remember, you're just adding the coefficients. So this is 9x. We still have the minus 10, and that's going to equal, on the other side, negative 2 plus 2, they cancel each other out, so we just have the 17. Now we're left with the two-step equation to solve, like we had done in previous lessons. So to get 9x by itself, we're going to want to add 10 to both sides. So we have 9x. And 17 plus 10 is 27. Now to get x by itself, divide by the 9. So x equals, 9 goes into 27 3 times. So the answer to this equation is x equals 3. Our second example is n over 2 minus 5 equals negative 2n plus 6. To solve this equation, what I'm going to do is I'm going to start by clearing the fraction. So even though there's only one fraction in the problem, I can already foresee if I were to add the 2n to both sides, I'd have the whole number 2 with the 1/2 I need to add, and it's just going to create unnecessary work for us. So what we're going to do is clear the fraction by multiplying every piece of the equation by the denominator 2. So I'm going to multiply the fraction by 2, the negative 5 by 2, the negative 2n by 2, and the 6 by 2. Remember, you can't just multiply the fraction. If you change the equation, you got to make sure you change everything. So we have to multiply every single piece. So when we simplify this, the fraction n over 2 times 2. The 2's cancel out because 2 goes into 2 once. So we have 1n, or just n, minus 5 times 2 is 10. That equals, on the right-hand side, negative 2n times 2 is negative 4n, and 6 times 2 is 12. So by clearing the fraction, you see we now have a much simpler problem to work with. So I want to get all the variables on one side. Right now I have n, and I have negative 4n. So since I like to work with positive numbers, I'm going to add 4n to both sides. When I add the 4n to both sides, remember if it's just the letter, we assume there's a 1 out front. So we have 1n plus 4n would be 5n minus 10. And on the other side we have a 12 because the 4's had canceled out. Then it's a two-step equation. So add 10 to both sides. That gives us 5n equal to 22. Because of course the 10's will cancel, and then divide by the 5. So 5 doesn't go into 22 perfectly, and we cannot simplify that fraction. So our final answer for this problem is going to be n equals 22 over 5. It is time for your next U-Try. Please pause the video and try to solve the equation 100x minus 20 equals negative 50x plus 8. When you have attempted the problem and have an answer, resume the video to check it. To solve this equation, the first thing that we want to do is get the variables on one side. So what I'm going to do is, since I have a negative 50x, I'm going to add 50x to both sides of my equation. When I add 50x, on the right, 100 plus 50 is going to make me have 150x. Still have the minus 20. And that's going to equal, since the 50s will cancel out, I just now have 8 on the right. From here, to get the x term by itself, I'm going to add 20 on both sides. So I'm going to have 150x equals 20 plus 8 is 28. And then divide by 150. Now clearly 150 is not going to go into 28 because it is just too big of a number. So what I'm going to do is leave my answer as a fraction, but I want to make sure I simplify that fraction. So 28 and 150, both of those numbers are even. So I know I can divide them both by 2. So when I divide both of these by 2, 2 goes into 28 14 times. 2 goes into 150 75 times. At this point, I just have 2 and 7, or 14, left to work with. Well, 2 and 7 don't go into 75, neither will 14, so this will be my final answer. X is equal to 14 over 75. If you got 28 over 150, that's good progress. Just make sure you always simplify your answers. This concludes today's lesson on solving equations with variables on both sides. If you have any questions, please feel free to ask Miss Brooks. Thanks for tuning in, and we'll catch you next time on your Daily Dose of Math with Miss Brooks.